Beneath the shimmering waters of Northern California's largest freshwater lake lies a sleeping giant, a volcano that has not erupted in more than 8,000 years, yet remains very much alive. Few realize that the idyllic landscapes of Lake County, dotted with vineyards and geothermal spas, sit atop one of America's most dangerous hidden volcanoes. The Clear Lake Volcanic Field, often overlooked and mistaken for extinct, is in fact quietly simmering beneath the surface, its molten heart still heating the ground, shaking the earth, and feeding one of the world's largest geothermal power fields. Beneath the calm surface of Clear Lake lies a chilling truth. This tranquil paradise may actually be a sleeping volcano waiting to awaken. Scientists warn that this unassuming region could erupt again, and when it does, it might happen with little warning. From phreatic explosions beneath the lake to lava domes rising from the earth, the threat is real and largely unknown. Today, let's delve into California's hidden volcano, the Clear Lake Volcanic Field, and the smoldering danger it conceals beneath its peaceful surface. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The story of the Clear Lake Volcanic Field begins roughly 2.1 million years ago, during a period of significant tectonic upheaval in Northern California. The region sits atop a tangled web of fault lines at the edge of the Pacific and North American plates. Unlike the linear chain of volcanoes to the north formed by subduction along the Cascadia Trench, Clear Lake's volcanism stems from a more complex interaction of crustal stretching, faulting, and magma intrusion related to the San Andreas fault system, and the northward migration of the Mendocino Triple Junction, a geologic point where three tectonic boundaries meet. As the crust in the area stretched and fractured, magma from deep within the earth began to rise, melting through layers of rock and producing eruptions that gradually built up the Clear Lake Volcanic Field. Over time, eruptions alternated between explosive and effusive, producing a mixture of lava. Some flows oozed gently across the landscape, while others erupted violently, forming large craters. The most famous feature of the field, Mount Konocti, dominates the southern shoreline of Clear Lake. Though it appears as a modest mountain compared to other volcanoes, it is actually a complex of lava domes formed by viscous dacitic magma thousands of years ago. Its rugged profile conceals evidence of explosive eruptions and pyroclastic activity, making it one of the most important markers of the volcanic field's dynamic past. Throughout its long history, the Clear Lake Volcanic Field has experienced dozens of eruptive episodes. Geological evidence shows that its activity has shifted over time, migrating from the northwest to the southeast around the lake. The most recent known eruptions occurred approximately 8,500 to 13,500 years ago. During these eruptions, lava domes formed and explosive interactions with groundwater-carved craters. Ash deposits from these events blanket parts of Lake County, silent reminders of the field's violent capabilities. As the eruptions waned, the magma chamber beneath the surface did not fully cool. Instead, it continued to heat groundwater circulating through the crust, a process that persists today and fuels the vast geothermal system known as the geysers, just southwest of Clear Lake. This geothermal activity is both a sign and a symptom of lingering magmatic heat. The same forces that power California's renewable energy projects are the very indicators that the region's volcanic system remains active. Scientists studying the area have found that portions of the crust beneath Clear Lake still contain molten or partially molten rock, with estimates suggesting about 5 to 10% partial melt at depths of 7 to 15 kilometers. To the untrained eye, Clear Lake's calm surface gives no hint of the restless processes below. But to geologists, the signs are unmistakable. The area experiences frequent seismic activity, much of it associated with geothermal energy extraction and regional faulting. Small earthquakes, typically between magnitude 1 and 3, are recorded almost daily. These tremors often cluster near the geyser's geothermal field, indicating that fluids moving through hot, fractured rock are triggering minor seismic events. However, not all of the shaking can be explained away by geothermal operations. Sporadic volcanic-type earthquakes occasionally occur beneath the field, signaling that magma may still be moving at depth. The U.S. Geological Survey and the California Volcano Observatory continuously monitor this seismicity, using arrays of sensors to distinguish between tectonic, geothermal, and volcanic quakes. Hot springs, gas vents, and fumaroles dot the landscape, releasing carbon dioxide and other volcanic gases. The composition of these gases is another clue. Volcanic carbon isotopes confirm that at least part of the emissions originates from deep magmatic sources. Furthermore, satellite-based studies have revealed subtle but measurable ground deformation in parts of the volcanic field, minor bulging and subsidence patterns that suggest changes in underground pressure. While these changes are not currently alarming, they serve as reminders that Clear Lake's magma chamber remains dynamic. The Clear Lake Volcanic Field is classified by the USGS as a high-threat volcano, one of the top-ranking volcanoes in the United States in terms of potential hazard. This ranking doesn't imply that an eruption is imminent, but rather that the combination of volcanic potential, population exposure, and infrastructure vulnerability makes the field particularly risky should activity resume. A future eruption could take several forms, depending on the composition of the magma and the location of the vent. One of the most probable scenarios involves a phreatomagmatic eruption, where rising magma interacts with groundwater or the lake itself. Such an event would be explosively violent, producing columns of steam, ash, and fragmented rock. If the eruption occurred under or near Clear Lake, it could generate waves, potentially damaging lakeside communities. Another possible scenario involves the formation of a new cinder cone northeast of the lake, where basaltic magma could erupt to produce lava flows and ashfall. These eruptions might resemble those that created cones in nearby volcanic fields, such as the cinder cone in Lassen Volcanic National Park. While less explosive, such eruptions could still destroy roads, farmland, and power infrastructure within a few kilometers of the vent. In the worst case, if magma of a more silicic composition were to rise, the eruption could become significantly more explosive. Eruptions of this kind often generate pyroclastic flows, fast-moving clouds of hot gas and ash that can devastate everything in their path. Although Mount Konocti is currently dormant, it has produced such eruptions in the past, and its magma composition suggests that future eruptions could be similarly violent. The question that inevitably arises is, will Clear Lake erupt again? The scientific consensus is clear. Yes, it will. Though the timing remains uncertain, volcanic fields like Clear Lake often remain intermittently active for hundreds of thousands to millions of years. The 8,500-year pause since the last eruption is relatively short in geologic terms. Geochemical and geophysical evidence strongly suggests that magma still resides beneath the field. USGS scientists estimate that the current volcanic episode that began around 2.1 million years ago is ongoing and could continue for at least another 200,000 years. While no signs currently point to an imminent eruption, that does not mean the system is dormant. The key challenge lies in prediction. Volcanoes like Clear Lake do not always give obvious warning signs until days or weeks before an eruption. Typically, scientists would expect to see clusters of small earthquakes migrating upward, measurable ground deformation as magma pushes toward the surface, and increases in volcanic gas emissions. Because Clear Lake already experiences frequent small quakes from geothermal and tectonic processes, distinguishing between routine activity and genuine unrest will be a complex task. The Clear Lake Volcanic Field may appear tranquil today, but its story is far from over. Geologists agree that this system is not extinct, it's merely in a dormant phase between eruptions. Deep beneath the rolling vineyards and calm waters of Northern California, magma still moves. Based on current research, the volcanic field is expected to remain intermittently active for hundreds of thousands of years. While no eruption is imminent, the system retains enough heat and partially molten rock to produce new activity at some point in the future. The next eruption, whenever it comes, will likely be small to moderate in scale, localized around Clear Lake or Mount Konocti. However, even a minor event could have major consequences for nearby communities, air quality, and California's energy infrastructure. Continued monitoring by the U.S. Geological Survey and California Volcano Observatory will be vital to detecting early warning signs. The future of Clear Lake lies not in if it erupts again, but when. For now, the region remains a delicate balance between serenity and volatility, a reminder that beneath even the calmest landscapes, the planet's fiery heart still beats.